Find the length AB. Join line MN. Label points Q and join line QN. Let the radius of the blue circle be r and that of the green circle be small r. It implies that line QM equals r minus the small r, which is the radius of the green circle. Line G equals 4 times the square root of 7 and line MN equals the sum of r and small r. By Pythagoras' theorem, the square of line MN equals the sum of the square of line QN and the square of line QM. Since line G equals line QN, substitute values. It follows that the square of the sum of 8 and small r equals the sum of the square of 8 minus the small r and the square of 4 times the square root of 7. Expand brackets and simplify. We have that 32 times small r equals 96. It signify that the small r equals 96 divided by 32, which equals 3 centimeters. Label points F and J. Join line J, N. Let Q F be equals to X, which is equals to J or N. It implies that line M F equals line Q M minus line Q, which equals 5 minus X, after simplification of substituted values. Therefore, the length of line M F equals 5 minus X. Label point K. Let labeled angle NKJ be equals to theta, which equals to labeled angle MKF. It is because vertical opposite angles are equal. Hence, line JON divided by line KN equals sine theta, which equals line MF divided by line KOM. Since triangle MKF is congruent to triangle NKJ. Substitute values and we have x divided by 3 equals 5 minus x divided by 8. Cross multiply. Eight times x equals 3 times 5 minus x, which equals 15 minus 3 times x. Combine like terms. We have that the sum of 8 times x and 3 times x equals 11 times x. The result equals 15. It follows that line FM equals 5 minus x, which equals 5 minus 15 divided by 11. The result equals 40 divided by 11. Consider triangle MKF and use Pythagoras' theorem. It implies that the square of line KM equals the sum of the square of line FM and the square of line FK, which equals the sum of the square of 6 and the square of x. Substitute values. The square of 8 equals the sum of the square of 40 divided by 11 and the square of line FK. It implies that the square of line FK equals 6144 divided by 121. Take the square root of the equation. Line FK equals the square root of 6144 121, which equals the product of 32 and the square root of 6. All divided by 11. Since line A F equals line FK, it is because line QM is an angular bisector of line AK. Line A k equals 2 times line F k, which equals the product of 64 and the square root of 6. All divided by 11 in centimeters. We call it equation 1. From triangle N, KJ. Use Pythagoras theorem. The square of line KJ equals the sum of the square of line KON and the square of line JON, which equals 864 divided by 121. After simplification of substituted value, take the square root of the equation. It follows that line KJ equals the square root of 864 divided by 121, which equals to the product of 12 and the square root of 6. All divided by 11 in centimeters. But line KJ equals line BJ. Line JON is a line bisector of line BK. It follows that line BK equals 2 times line KJ, which equals the product of 24 and the square root of 6. All divided by 11 in centimeters. We call it equation 2. Add equation 1 and equation 2. The sum of line A, K and line B, K, which equals length AB, the result equals the product of 8 and the square root of 6. In centimeters. After simplification of substituted values.